we're going to look at the surface of Mercury, kind of like a planetary geologist would. Our goal is to try to understand the history of the surface, how it's changed over time. And what I hope to do is be able to illustrate that contains information about the history of our entire solar system. So let's take a look at Mercury. This is a recent map that was made by the Messenger spacecraft. So the first pictures that we had up close of Mercury was from the 1970s, and those were actually the last pictures we had of Mercury up close until Messenger arrived there after 2010. And so we have now maps of the entire surface of Mercury, and we can see them really nicely here in this Google Earth simulation. It's not as nice as we might want. Like if you look at the whole thing, there are a few missing patches, and there's some things that look kind of weird, like this big, huge stripe across the planet. And that's not real. In fact, these pictures are illustrating something that astronomers have known for a long time, which is if you've ever looked at like a crescent moon, you'll know that when the part of the moon that's in like the steepest shadow actually looks like the most bumpy part of the moon. So if you actually, like say you were, this is Mercury, but say you wanted to look at the moon through a telescope, if you looked when it was a full moon, it actually doesn't look that good. The craters look kind of flat, kind of like this. You can't really see them. But if you want to see the craters really good, then you look when it's just a crescent, and that way the shadow casts across the surface, and you can see all these craters that kind of pop out. And so there's some artifacts in this picture, in these pictures. In fact, we can see the craters way better on this part of the planet, just because of the lighting. Really, it has nothing to do with anything else. Now, there's some other things we can see here. First of all, there's nothing of anything like what we see on Earth in terms of oceans or anything like that on Mercury. I mean, it's just a big, huge ball of rock, and there's a ton of craters. I mean, that craters are the dominant feature. And I want to show you a couple of these craters because they illustrate sort of common things that craters have. So a crater generally will have a big impact right in the middle, right, like a big divot. But then sometimes, depending on where the crater hits and how fast it's going, it'll create a couple things. One is it'll create kind of this white area around it that's called ejecta. What happens is like dust and debris is thrown up into the air, and it lands back on the surface, and it's kind of brighter than the other parts. It'll also make what are called rays. So again, that's dust and other material that's thrown out into the air in long straight lines away from the impact. You can see a bunch of those kind of rays here. Let me show you again here. There's kind of an ejecta circle around it, and then there's these rays going off in all directions. Okay, so those are some features that we tend to see. Now, I want to zoom in on some of these craters because what we can start to do is kind of piece together a history of the surface. So let me just go in. I'll just zoom in here to some small part, and I'm going to look where the shadows are strong because I think it illustrates the craters much more clearly. Now, you'll notice that I can start to kind of figure out which craters happened first and which craters have happened more recently. So as I look at these craters, I can see that they're overlapping, and some are on top of each other. So like I can see that this larger crater here must have happened first because another crater came a little later and was kind of a circle right there, and then another crater came later, and then another crater came later. Yeah, and so I can kind of see here that the sequence of impacts, right? Now these craters are caused by big rocks and asteroids and meteorites coming and hitting the surface of Mercury. Now these kind of craters are probably caused by relatively small impacts. You know, they aren't like they would destroy the whole planet or something like that. But we can see their impact is sort of preserved. By the way, the actual thing that would come in and hit would be much smaller than the crater itself. The crater is usually 10 to 100 times bigger than the actual object that hit the surface. Nonetheless, we can see here's a big crater, smaller, 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 and that's a pattern that we tend to see. That if you look at craters that are stacked on top of craters, they tend to get smaller over time. I mean, you rarely see just a huge crater that came in later on. Let's take a look at another part near here. See if we see a similar story. So like, here's kind of this is a nice case. Right, we see there's a big impact right here, and then a smaller one almost right in the middle of it, and then kind of some medium-sized ones all the way around that clearly came later. And if we look inside some of those medium ones, we can even see some really tiny craters inside those. So we get the sense that this kind of continues onward, where you keep getting smaller and smaller impacts as time goes on. Right, we can see the same thing here, a big impact, kind of a medium one, smaller ones. And as we get even to these smaller craters, they have small impacts inside them that must have happened more recently. We can also see there are some scarps. We read about that, like a line kind of like this would be a scarp. There's another one over here. Let's see, it's really these kind of like ridges. Yeah, here's a nice big one. Okay, these kind of ridges along the surface of Mercury. And you can kind of say, now, did these happen a long, long time ago, or did they happen more recently? So here's a relatively small crater, and I can see that there is no scarp line through the crater. So this crater must have happened after the scarps formed. So those scarps must be older, at least, than this crater. So you start to see how we can piece together, if not like actual how many years, we can at least put a sequence together, a timeline of the surface of the planet. And one of the things we can conclude is that over time, the impactors, like these meteorites and things that came and hit the surface, kept getting smaller. So as we picture back to our solar system, we start to develop an idea that earlier in the solar system, there must have been really big things flying around, like big rocks just whizzing around by the planets. And as time went on, those big things hit the planets, and all that was left was some more medium-sized things. And as time goes on further, it's smaller still, to the point where today, the kind of things that are potentially hitting these planets are really quite small, because all the big stuff has already hit the planets. And that fits really closely and kind of informs our understanding of how the entire solar system formed. So if you play that back, that would lead us to believe that there were once, long ago, really large things that could have hit the planets. And we see some evidence of that on Earth, that some of the oldest craters on Earth are actually extremely large and maybe contributed to like the extinction of the dinosaurs. But we can also see that on the other planets. There are some enormous craters. Here's one on Mercury, a huge crater from a long time ago. And in fact, there are some of these have specific names, like the Caloris Basin on Mercury. I'm trying to think if that's this. It seems to be that this is the case, that this is the Caloris Basin, which is, I mean, if you look at the whole size of the planet, you see that's a huge crater. So it's believed that early on in the history of Mercury, there was an enormous impact that hit Mercury. This caused this Caloris Basin. All right, so what you're going to do shortly is you're going to look at images from the moon, and you're going to try to see if it tells a similar story as these craters on Mercury. And to do that, you're going to use Google Moon, which is just like a Google map, except it has pictures of the moon. All right, and so it's a great way that you can explore the whole surface of the moon. And there's lots of different maps. This map shows the Apollo landings. You can use just a visible map like this, where you can zoom in and see sort of more detail. But I find, kind of like that whole shadow thing, to get the craters to really pop out, this elevation map, which was made by measuring, like using a laser to measure the elevation or topography of the whole surface of the moon, it just allows you to really see the craters clearly. And so then you can explore this. I'm going to ask you to take some screenshots and see if you can see some things like scarps, see if you can put together a history of the surface of the moon and kind of compare that to the surface of Mercury.